So today let's talk about slope-intercept form. Slope-intercept form is probably one of the most popular formulas or equations that's associated with graphing linear equations. And it looks like this: y equals mx plus b, where the m stands for slope and the b stands for y-intercept. And anytime that you have an equation that's written like that, you will automatically know the slope of a line and where it crosses the y-axis. So let's take, I got a couple equations written here. Let's see if we can find the slope and the y-intercept right away. So let's take a look at this one here. Well, this one, okay, notice the 3 right in front of the x, that would be my slope. So slope is 3. Y-intercept is, now it's minus 2. Notice it's plus b, so y-intercept would be negative 2. This next one, slope would be negative x, so it would be negative 1. And y-intercept would be negative 4. This one right here, it says x over 2. Now be aware that's the same thing as 1/2 x, so my slope is a half, and my y-intercept this time is 6. Now these next couple are a little tricky because they're not written in slope-intercept form, so you have to put them in slope-intercept form. And so what you would have to do first on this one is I would subtract 5x, and you get y equals negative 5x plus 10. So my slope on this case would be negative 5, and my y-intercept would be 10. This one takes a little bit more effort. I would again subtract 5x. So I get negative y equals negative 5x plus 10. And then I divide everything by negative 1. So you get y equals 5x minus 10. So in this case, my slope would be 5, and my y-intercept would be negative 10. Last but not least, this one I would subtract 4x. So I'd get 2y equals negative 4x plus 12, and then I divide by 2. So I get y equals negative 2x plus 6. So my slope would be negative 2, and my y-intercept would be 6. Okay, fairly straightforward. Now, the only difficult part with any of that was maybe these last couple where you had to write them in slope-intercept form. So let's go backwards. What if I asked you or told you here's slope and here's y-intercept, write the equation? Well, this is pretty easy because, for instance, on number 1 here, I would just write y equals negative 2x plus 3. I'm done. As easy as that. I simply plug in for the m and the b. This one would be y equals negative 5x plus 0, which that's kind of silly. You don't need to write that, so it would just be y equals negative 5x. This one would be y equals 0x plus negative 4. And again, that's useless. You don't need that, so that's y equals negative 4. The bonus question here is, what kind of line is this? And that would be a horizontal line. Anytime you have slope 0, it would be a horizontal line. Last but not least, fractions, don't let those worry you. Y equals 1/4 x plus 2/7. Okay, hopefully that all makes sense so far. So let's talk about the last thing here. What if I ask you, does a certain point lie on a line? For instance, negative 2 comma 5. And let's say here's my equation of a line. And I don't actually know what the graph looks like. I don't have a picture of it, so I can't actually look to see if this is on there. But how would I be able to tell that mathematically or algebraically? Well, what I would do is I would just plug in. Remember, this is the x-coordinate and y-coordinate. So what I can do is I can simply, for y, I'll plug in my y-coordinate. For x, I'll plug in the x-coordinate. And if the left side equals the right, then yes, that means this point is on this line. So I get 5 equals, this would be 4 plus 1, so 5 equals 5. Yes, this one does. What about the next one? If I asked you, what about this point? Well, let's see again. I would just do 4 times 0 equals 3 times negative 2 minus 4. This is 0 equals negative 6 minus 4. 0 equals negative 10. No, this one does not. This point is not on that line. Last but not least, what if I did this last one? So this one, it's 2 times x, so it's 2 times 4 minus 5 times 3 equals negative 7. 8 minus 15 equals negative 7. 8 minus 15 is negative 7, so yes, this one is. And that's all there is to it in terms of figuring out whether or not the point lies on the line. Okay, and that's the beginning of, I guess, slope-intercept form.